So today, Electropages is here in Munich at Electronica 2022, and I'm joined by
Thomas Halkier, Neocortec.
Fantastic. Thank you for having me.
Sure, thanks for coming.
So my first question to you for the audience is, what is it that your company does and where it goes?
Sure. So Neocortec is a company who specializes in wireless sensor networks. We provide a protocol stack which is optimized for low power consumption for all the devices, high level of scalability, and basically long-lasting performance, you say. So imagine a big building where you want to deploy sensors. You want them to run for years and years on batteries. You don't want to install repeaters. You don't want to have a, let's say, complicated setup of devices and configuration. NeoMesh will handle that for you, basically. So the sensors become your network, and basically once you deploy the sensors, they will create the infrastructure required to basically carry the data towards a gateway, for instance.
And you mentioned about low power, because a lot of there are lots of protocol stacks out there, but they often have issues with energy efficiency. So that clearly might be an important thing in the future.
For sure, it's an important thing, and low power is such a, let's say, used term, because everybody says they're low power, I guess, to some degree.
How do you define that?
Yeah, exactly. How do we measure it? So for us, it's about creating a system where you can actually deploy low power sensors, and not having to do anything else. So with other mesh network, our technology is a mesh network. So with other mesh network technologies, you usually rely on routers and repeaters that needs to be mains powered in order to build your network. That's not how it works here. Basically, everybody will fully participate in the network and route data and forward data on behalf of the others, and while still being battery powered. And that allows us to basically run a full functional node at less than 20 micrograms.
That's less than 20 micrograms. Blimey. That's caught me off. That's 20. Really? That's really low. So, so in terms of the network structure itself, it sounds like it's quite decentralized. There's no central controller. It's all a mesh network, basically.
And that's the point. And the reason why our network scales really well is because we've distributed the network management into all the devices. So in other technologies where you have a central unit who coordinates the network, you can imagine that as it grows, that task becomes more complicated. The amount of data that you need to exchange between the devices to organize who becomes neighbor with who and fix routing paths and things like this becomes more complicated. So they don't typically scale really well. So that's exactly the point, decentralized management.
And so I suppose that also means that the reason why you can get that lower power consumption is because if you've got a mesh, and you only need to talk to the devices that are immediately around you.
Yes.
And if they're quite close, you only have to send a quick message, and then it basically trickles down the mesh.
Right, that's part of it. And the other part is we synchronize the devices very tightly on time, which means that we can allow them to sleep and wake up at predefined intervals and exchange communication with each other and go back to sleep. So that's how we really conserve the energy.
That's brilliant.
Yeah.
That's absolutely, that's brilliant. So, because I think it's LoRa, how you pronounce it, that has issues because you can send a message, but you don't know if anyone's heard it, and it depends if anyone's listening at the time.
Yeah, that's true. There are ways of acknowledging LoRa transmissions as well. So I mean, I don't want to say one technology is better than the other. Actually, I'm presenting at the Wireless Congress in an hour from now, talking about mesh networks and what you can do and what you can't do. And the point is really, there are so many different types of various wireless technologies out there, and for somebody who needs to select a technology, you need to understand, for a certain application, which technology makes the most sense. And LoRa, like you mentioned, star network, fine for a lot of applications. Mesh networks allows you to go deep indoor, underground, areas where you don't have easy access to a gateway, for instance.
But like you said, if you've got that synchronization across the whole network, you can minimize power so much, because you know that the moment they all come online, they can all quickly talk to each other, and then all synchronously go to sleep.
Yeah, it happens not so that everybody sleeps at the same time and wakes at the same time. It's a little bit more advanced, you could say, but the point is, the devices, if you look at a single device who is fully participating in the network, he will sleep most of the time.
Yeah, and so that helps really minimize the energy consumption. And I suppose that's quite important if you talk like smart cities and smart spaces.
Yeah, I think, that's certainly an application area. One of the applications area we are focusing on right now is smart commercial buildings, big buildings where you deploy a lot of sensors. In particular, so now these days where there's so much focus on energy and energy consumption. So some of the older, bigger buildings, they are not pre-wired to be smart. So here with this technology, we allow them to retrofit sensors, actuators, and so on to better control the temperature inside of the building and lower the energy consumption.
Well, that is, I think that's a major problem in places like Europe, especially because a lot of our architecture is very, very old. And the buildings are beautiful, but like you say, because they weren't designed with smart cities in mind.
Exactly.
You can't start pulling walls out to put cables in. You have to find solutions that can just retrofit into those buildings.
Right. Exactly.
Brilliant.
Yeah. And the thing is, you can do it really quickly. I mean, it's something. Yeah.
Stick, and then it's on the wall, and it's
right. Exactly.
Yeah.
So for sure, it has advantages. Yeah.
That's absolutely brilliant.
Yeah.
So we looked at smart cities and mesh networks. What other areas of applications are you looking to target with this solution?
We believe smart agriculture is a big area we will be targeting. So again, optimizing on the use of fertilizers, improving the way you use water, these type of things. It's all about getting data to support what you're doing, and I think there's a lot of focus on that. So obviously, being able to deploy a network that doesn't rely on any set infrastructure already being there, then that gives some opportunities, possibilities. So that's certainly an area.
Now, you've got something in front of me here, this device that I think you said a student made. Now, there's one thing that's always bugged me about a lot of protocols and sort of like and standard stacks. And what it is that they're often very complicated to use, or the documentation's difficult to understand, the APIs are unclear. And what I would like as an engineer is something that's very simple to use. I have to drag and drop, or I just have a very basic API or something like that makes it very quick to integrate. What's going on here?
Yeah, so it's a good point, and it's one of the things, we talked about the features of our stack. One of the things that we've been focusing on from the beginning is to make it easy to work with.
Yeah.
So for instance, our dev kit, we had when we designed our dev kit, we had it as a target from when you receive it until you have a mesh network run, it shouldn't take more than a minute.
Right.
So that puts some constraints on how you build such a dev kit. But one thing is talking about how easy it is to work with, another thing is showing it, obviously. So this summer we had a new intern joining us, first year engineering student. So we challenged him, say, why don't you build a demo setup for Electronica? You've got 2 months to get it going.
Not a lot of time then.
So he built these sensors, 25 of them. On Monday when we arrived here, we installed them around this part of the exhibition hall. Of course,
brilliant.
got acceptance from
Just start sticking sensors on people's boots, start telling them.
No, it's a student project, so everybody thought it was a great idea and liked the idea and has come here to see the result of it. So basically, we installed the sensors on Monday.
Yeah.
And this allows us now to demo with the screen behind you there how the network is actually operating. So it's turned out to be a really useful communication tool to talk about how the network operates. But then also it shows clearly how easy it is to deploy. If you can do it in 2 months, then
Brilliant. So let's say there is an engineer out there who wants to consider using Neocortec solutions. What would you suggest they do, and how would they contact your company?
Right. So I think the best thing is to start with our dev kit. We have basically this box that has 5 evaluation boards sitting in it. It has everything you need. It has sensors you can wire, you can connect to external microcontrollers.
And if I remember correctly, you don't just supply the software stack, you also supply hardware modules,
right?
don't you?
Exactly. So you're absolutely right. Our core IP is our software stack, but we supply it in fully integrated, pre-certified modules.
And that helps engineers a lot to integrate those your solution into their product.
It's just a low threshold for getting into using it, really. And so we offer modules for sub-gigahertz 868, 915, and then also at 2.4 gig.
Oh, so you use 2.4 gigs as well?
Yeah, I will say though that most of the customers lean towards the sub-gig.
I suppose because it's longer range, lower energy, that kind of thing.
Yeah.
So if an engineer wants to contact you or your company about the products you sell, what would they do, basically?
We have actually a very good setup for interacting with the customers on our website. So there's a support channel that you can access, get direct connection to our engineers and ask questions. So we are very easy to talk to.
Fantastic. Well, thank you ever so much for taking the time to talk to us today. Thank you very much. Thank you.